All right, hello everyone. Thanks for coming to the workshop today on LaTeX and Overleaf. If you want to follow along the presentations, I put the link in the Discord. And also we'll be referring to this LaTeX Overleaf document. While we're doing examples, we'll be coding directly on it. So if you want to follow along while we do that, you can click on that link right there. But otherwise, everything will be screen shared. So you can just chill, eat your lunch, and we'll do that.
Okay, so in this workshop, we're basically just going to explain what LaTeX and Overleaf are, general tips for writing your paper, how to write like equations and like other like math symbols and stuff in LaTeX, how to insert images into your paper, create tables, put your references in, and other formatting tips that you might need.
So before we jump into the LaTeX specific stuff, here's some general tips overall when working on this for your paper. Make sure you start, please start early on this. Do not be one of those groups who leave it to the last 3 days, 2 days, maybe even the day of, because LaTeX is, the formatting is definitely a little tricky if you're not used to it at first. And IEEE citations take quite a bit of time because they are numbered orders, so you may need to adjust your numbers accordingly here and there. The recommendation is that you start writing your paper, drafting it up in Google Docs. This way it's easier to leave comments and then copy it over to Overleaf. But don't discount that you're copying and pasting something over to Overleaf. As I think you'll kind of see here today, we will be showing that, the formatting takes a little bit. You can't just easily copy and paste everything. And so if you see this link right here, we mentioned this in the research presentation earlier this week, but this is the IEEE template made for the GSET journal. This was made by a past RTA. It's really good, but we'll also be giving you some extra tips around it because there are definitely some tricky things with it because this RTA was really good at LaTeX, but we'll try to give you some simpler ways of doing things that make it easier. And lastly,
it's LaTeX.
Bro, it's June. The other RTAs.
Oh my goodness. June. All right.
Oh, this writes really good.
Yeah. Wow. All right. I'm gonna just mute them real quick. If I can. There you go. All right. We'll keep on going. We will not be deterred. Lastly, I would say if you don't know something, that's completely okay in LaTeX. My recommendation is to Stack Overflow it, Google it. Your problem is probably going to be very common. There's a lot of existing questions out there for these type of things. And to try to look there, or if you don't know, ask an RTA, of course, we're always here to help you. And lastly, I just want to highlight this very true statement over here. No matter how absurd or bizarre something is, if it's in LaTeX, it must be true. So, whatever you write, it's in LaTeX, it must be true. I recommend checking out the Facebook group. There are a lot of funny memes on there. So.
Okay, so LaTeX, as it says, is a markup language for creating PDFs used in research, and it makes it a lot easier to insert equations, symbols, and it just makes the overall formatting of the paper just look a lot nicer. And Overleaf is this platform where multiple people can work on the same paper at like the same time. It's specifically for LaTeX formatting and everything.
All right, so we're just going to jump right into writing things in LaTeX. To answer Sahil's question in the chat, I think I pronounce LaTeX or LaTeX a bit strangely. So I believe if you ask more people, I think it might be LaTeX. That's my guess, but I think I pronounced it LaTeX because I'm a little bit strange. It's the other way?
You pronounce it LaTeX. And I think many people would agree. But yeah, Sahil, if it is in LaTeX, it must be true.
All right, there you go. You heard it from Lasya. So with that, we're going to jump right into math mode. So this is sort of the really neat thing about LaTeX, that a lot of people really use it for. It's writing these really fancy equations. If you ever tried inserting an equation on, say, Google Docs or another platform, it has this really tricky, user interface that you have to click and drag and drop, and it doesn't look nice and doesn't format properly. Well, LaTeX is really good in that it has, this sort of language to allow you to write these equations. And so it's really nice. There are two key things to know about when starting to write in math mode. So math mode, these refer to inline equations. Inline equations are just equations within the sentence. So if you're saying this is the Pythagorean theorem, you would do $ a squared plus b squared equals c squared, and then close out to put that in the sentence. However, if you don't want to put in the sentence, you want to sort of highlight it and center it and leave it alone to sort of do that, then you would use display mode, which if you are, there are two ways of doing it. You can use the slash bracket here and put your LaTeX in there, or you could use the $, which does the same exact thing. The reason it does that is just for, old software development reasons. Lastly, I will say this is a really useful tool. I'm just going to click on it right here. So this is the Textify. Basically, if you do not know a character in LaTeX or a mathematical symbol, then you can always just put it in here and it will classify it for you and figure out what it is in LaTeX. So I'm just going to ask, does anyone have a mathematical character or something fancy that they would like to know the LaTeX for? Give me a symbol that I might be able to actually conceivably draw, so I don't, destroy myself. Integral, infinity, square root. Well, I see someone said alpha. I'm going to put alpha. So I think alpha looks something like this, right? And then there we go. We have alpha right here. You would do this in math mode, and you can just copy this right into there. So with that, we're going to start doing a demonstration of how to do that exactly. So going to our Overleaf document right here, Lasya and I compiled this Overleaf document to try and sort of give you guys a general sense of how to interact in LaTeX a little bit. So with that, as you can see, here's the general format. A lot of this is like, laid out commonly within the template we give you. So up here, this is known as the preamble. This is where you import any specific fonting or mathematical packages or formatting, anything you want to import a package as, it's up here. In addition, you define certain variables. So in this case, we have, defined a set thing for the title, author, and date. And this is where you actually run the rest of the content you're displaying. This is in the body of the LaTeX document. So with that, we're going to jump down to this equation section as right here. As you can see earlier, we talked about inline equations which look something like this, as you can kind of see better sense. And then if you want to do display mode right here, you could see the $, right here. So with that, we're going to try to add an extra equation real quick to try and give an example here. So does anyone want to give, a sample equation for us to do? Feel free to, actually, I don't know if I see everyone, so feel free to do something. Oh, actually, great one from Emma, the quadratic formula. So let's see if I can remember the quadratic formula without embarrassing myself. So we're going to do x equals negative b plus or minus. I think plus or minus is plus minus, something like that. Actually, we can look up on Textify plus minus, and okay, plus minus. Plus or minus the square root of b squared minus 4ac all over 2a. Okay, now we got to make it a fraction. So we're going to divide it right here. So with that, if we render this and scroll down right here, we can see there we have it. We have the quadratic formula. So just to give a breakdown of what this sort of thing is, as you can see, it's pretty straightforward for the most part. There's maybe a couple of things that would be difficult to understand. It sort of starts off writing equations pretty normally. And if you want a negative, you put, negative that a variable, put a square root, there's this abbreviation that kind of makes sense. If you want to do a superscript, you do an upper caret. If you want to do a subscript, you do a lower caret, like a lower bar like this, and it becomes a subscript. But yeah, it kind of generally makes sense here. The one thing that may be tricky is these curly brackets and frac. Frac converts what's inside the curly brackets with two parameters into a fraction, which, if you kind of get the feel for, that's what it looks like. But yeah, that's sort of the general thing. To highlight Vinay, I actually did put Gauss's identity all the way down here because it's pretty cool. I guess we'll try to do one more. What if you have a subscript and a superscript on the same number variable? That's a great question, actually. So this is where the brackets come in handy because the brackets sort of act as your grouping symbol. So let's say, I don't know, for example, you do like say, the sum of, let's say the sum of a bunch of different square variables. So let's do like y is equal to x sub 1 plus x sub 2 plus x sub 3. But then let's say we want to then make these squared. So what we could do, I believe, is if we put these grouping symbols around it and just square it, this helps sort of act it as well. The grouping symbol here with the curly brackets sort of just acts as a way to keep things organized. And actually, if you find it right over here, it looks kind of like this. You actually can play with this a little bit and realize that if you even do it without here, you can figure out that LaTeX sort of figures out the formatting for you pretty straightforward. So if you do this, it sort of squares the immediate character after it. And so if we render this, you see, okay, this is probably what looks a bit better. So you want to use that going forward. However, one thing to note is, let's say you want to do the number 20. If we render that, well, that's sort of going to be a problem, right? Because it only renders the first character. So for this, you always want to make sure you put a little bracket around it to ensure that it knows to square the entire thing. But with that, yeah, that's sort of how you do it. Let's see. Why is the exponent of b a subscript? Oh, I just did that as an example to show subscript. Oh, okay. Right. So I guess then, if anyone has any questions about math, the math thing is the math mode is definitely the core thing. This is what you can use on, like, maybe if you want to do this on homework or something like that, this is what it's commonly used for. But yeah, a lot of this I recommend using either the Textify if you're not too familiar with the exact symbol, because some of them can get crazy. Like, for example, one off the top, I don't know what gamma is. Wait, maybe gamma is pretty straightforward. Okay, yeah, gamma is actually pretty straightforward. So characters like that you may want to look up, and I especially recommend doing documentation. The Overleaf documentation is very good. I think I linked it in one of the slides at the end for different kinds of things. So, for example, if you want to write matrices, which is matrices, which is what I put right here, then you can see you could render it sort of nicely like that. But with that, that's the sort of end of math mode. I put a couple of examples with limits and integrals, which are pretty common as well. Yeah, unless anyone has any other questions, we're gonna try to move on to the next concept. Oh, how would you write a limit? If you look on the document, there's an example right over here. So there's a lim delimiter in LaTeX, and then you could just indicate the range as a subscript of what you want to render that way. But with that, I think we're going to move on to the next part.
All right. So images. So you guys are most definitely going to need to insert images into your paper. So if you want to do that, you can upload the image to the project. At that point, you can rename it to whatever you want to like identify that picture. And I'm gonna use the /include graphics to insert that image, and next to that in brackets you're going to put a scale, and the image scaling can vary, so you really just have to look at the paper, just maybe just recompile it a few times with different sizes to sort of figure out like which size you want. And in curly brackets after that, you're going to put the name of the image that you uploaded, so you know that that's the image that you want to insert. So Benson, I think we just showed that on an example. Yeah, so if you go here, so something that I just want to say first, you could see there are a lot of comments, stuff that we commented out here. I just want to reiterate, please start early on like doing the paper with all the formatting and stuff, because especially with the images, it can be like annoying to get them in a way that you want. So we actually like tried a few different things, because there are like multiple ways to insert images into papers. So we kind of just like tried a bunch of things. We used the template that was given by IEEE, and we tried that, and we kind of found that when you used the /begin figure, it didn't really work the way that we wanted it in the paper versus like just completely removing that. So yeah, it could really just depend on your paper. Okay, so here you could see, oh, did you uncomment it, Benson? Okay, yeah. Oh. All right, so here we have include graphics, and we have a width. We put 0.5. And if you want to put a width, you have to do like / like text width after that. Versus like if you just put a scale, it scales the image. If you give it a width, it doesn't really like have the information to like size the image. And then afterwards you could see the name of the image that's it's on the side of the project. So if I were to change the number here, let's say, so say I think the image is a little too big, so I want to make it like 0.3, then you can recompile it. And see, now the image is smaller. And then below the second image, we used scale for that. So you just scaled it directly. So, and yeah, and we also like have the centering. So if you most likely want to center the image, and you can do this in two ways. One is doing like /begin and center, and then whenever you do like begin, you're gonna have to end it afterwards. The other way is just directly saying like / like centering. Both ways work, as you can see. So I guess like now we can just do an example for that. Do we have any images? I don't know. All right, I guess I can upload an image. Oh wait, Benson, do you just want to show the upload button is in the like top left?
Yeah, sure.
It's over
Yeah,
there,
sure.
yeah.
So here's where it is. You can upload from your computer, and yeah, this you could also upload different kinds of files, but typically this is how you can upload an image.
Right. Okay, so let me upload something. All right. So yeah, now you can see we uploaded an image, and then Then you can use scale here, say 0.5, probably be a little big. And then just use the name of the picture and then render it. You can see it shows up on the paper.
Just one thing to highlight before we move on. You probably noticed that when we uncommented this, this code corresponds to this image, which if you notice goes before the code of display mode when we put the code of display mode up here. So in the code, it's after and here's before. This is why you really should start early, because you may run into unfamiliar parts of the LaTeX like this that don't make sense to you at first. So in particular to image, figure is particularly tricky to use because it uses float adjustment. Basically, it means LaTeX figures out the positioning for you. And so because of that, it puts it where you may not want it. So, to fix that, you can uncomment it. And you could use a very much simpler format of without the figure to do that and recompile it that way.
Yeah, I have a question.
Yes.
So for the include graphic where you have the text width, like backslash after the width, what does that do again?
I think the width, so it's like using this is like kind of like an arbitrary number, I think, when you're putting it in. And so it doesn't really have like a reference point to size the image. So then when you put the backslash text width, it like sort of uses the width, I think, to figure out how to size the image.
Okay, thank you.
Okay. And yeah. One last thing. So captioning the image. So I think the caption thing is currently not commented out.
Yeah, the caption.
Yeah.
Caption corresponds to figure. So if you want to do a caption
Yeah.
inside something like this, it's best putting it as like text. So.
Yeah. Okay. So yeah, you could put the caption.
Yep, you could put a caption like this, which figures out the numbering for you. But
yeah.
if you don't want to use figure, then you just have to write it as actual text. So
Yeah. So the other way is say you want to like put it in like, let's say like bold. So we'll go over this a little later, but if you want to put like text, like bold text, then you just do text. But yeah. That's not centered, but yeah, it's basic idea. Oh yeah, because it's outside the center thing. So all right.
And yeah, there you go. As you
Not
can
fully
see,
centered.
the formatting is definitely very tricky. So you're gonna have to spend some time on this to figure it out. Oh, there's a question. Oh, okay. Thank you, Saha, for answering the question. Yes. All right. Moving back to the slides, the next thing we'll cover is tables. So you may use your tables very commonly there. So tables, as you probably saw, work pretty similar to questions. Oh, I see where Joshi had a question about image on the left or right side of the paper. We'll get back to that in a minute because that relates to spacing. So by default, everything in LaTeX is left shifted. But I think you have to change a setting to make it right shifted, which requires you adding some stuff to the preamble, which I don't know off the top of my head, but that's the short answer. We can show you how to left shifted in a second. I don't have something right shifted off the top of my head. But going back to tables, you start every table begin, end, and tables are sort of just entries of different LaTeX symbols and characters. And so the way you delimitate entries is by the ampersand symbol. And to start a new line, a new row on the table, you do the double backslash. And so as we can, if we click on the table documentation of LaTeX, as you can see, there's a lot of table examples instantly, which is kind of crazy. And if you start to try and figure it out by hand, you'll see it gets tricky very quickly, especially with the strange formatting and different shifting and items like that. So what we've included is that there's this great tool that allows you to generate LaTeX tables for you automatically and just copy and paste it in. So for example, we have this table right here. I'm just going to copy and go down to the table section and paste it. There's a table right here. Paste a table right here. And as you can see, if we scroll down, oh, wait, hold on. I believe, oh, is it tabular import? There we go. So if we do that, oh, that is not what I thought it was. As you can see, I am struggling quite a bit because this is quite tricky. Oh, okay. Wait. I believe it's something. Okay, there we hopefully go. There you go. So just to specify a little bit, these entries are just parameters for a table that help delimitate the formatting here and there. As you can see, that may not be intuitive at first what exactly they mean. I'm actually not sure what exactly those characters means. I've just used them before. But yeah, if you use this particular tool, you can figure out your formatting pretty straightforward and to create unique formatting for different columns. Like for example, oh, this indenting, yes, because I was a bit, yeah, I just wanted better formatting for the indentations on these lines. So as you can see, yeah, indentation does not matter at all, or it does matter in some cases, but tabs do not matter. They just help formatting. But HT, as you can tell, prevents an error from being thrown entirely. The believe what it does is that it allows LaTeX to consider this entire thing as a float. So a float is basically something that LaTeX has control over. It gives it autonomy to figure out the formatting for itself. Otherwise, we'd have to specify the formatting, like the specific spacing and things like that automatically, which is why when I deleted it, as you probably saw earlier, it threw me this bad warning and did not render at all because it actually moved down here. So it threw a warning, indicated that it didn't work. But HT, what it does, it ensures that the table is in line and follows the correct format positioning right here. So hopefully that makes sense. Okay. So that is sort of tables. Oh, and to answer Rajoshi's question from earlier, if you scroll back up to images, we have the GSET image. If we simply don't center an image, it is automatically left adjusted. So you can use that while compiling. All right, let's switch back over. And if anyone doesn't have any questions on tables, we can move on.
Okay, so the bibliography, at the end of a sentence where, so you see like 1, 2, in like the example, you're basically gonna put a backslash cite, and yeah, and like right there. And then in the bibliography, you're gonna have like backslash bib item. And the way that you sort of like link the two is you can either put like a number, sort of like variable, like something to basically say like, okay, like this is the, for you to know this is the the citation for like this specific like reference in the paper. And it will automatically, in the order that you have the citations in your bibliography, it will number them in the paper. So if you take like your first citation in the bibliography, say it's like, maybe it might be like the 5th one that you have like numbered in your paper, but it will say that it is number 1 in both places. And yeah, you could use that link to cite stuff. Yeah, so if you go down at the bottom, you can see that, right, so every bibliography you need like / begin the bibliography and end it, just like for the other stuff. And this number here is sort of just like an arbitrary number. I think that's like supposedly like max number. But you could just put like some arbitrary number there. And then here at where the text is, you could see that the first one is hello and the second one is scholars, but then in the bibliography we listed scholars first, and so then that was numbered 1 and the other one was numbered 2. So if we just add a random one like after the period, so say cite example, and then I want to add it in the middle, then it should shift everything, or it should just shift the flow. Right, so you can see that now it's showing 3, 1, 2, because the example is now the second one. So just keep this in mind, that like the order in your paper might not necessarily like align with the order in the bibliography. So yeah, just like the order that you have the links down in the bibliography, just make sure to keep that like in the order that they appear in the paper, and then it will just show all the references in the paper will be in number order. Benson, you're muted.
Sorry about that. So just to move on here to discuss miscellaneous formatting tips. There are a couple different spacing vertical and horizontal options that we'll talk about. And we'll talk about escape characters, which are just in LaTeX, there are reserved characters like the ampersand, but you want to use the ampersand in what you write. So you have to escape those, just quickly use the slash. And then here's the very funny part of LaTeX, in that in everything, there's a section, there's a subsection, and then of course, if you want to go even further, a subdivision of what you're writing, there's a subsection. Unfortunately, there is no subsection or no subsection. It only goes down to this level of subsection. But let's hop over to just demonstrate that real quick right here. So as you can see right here, here's the different ways of writing section. So I wrote a subsection here about sections, and here's a subsection within that section, and here's a subsection within the section. The only reason I added an asterisk here is because if you add the asterisk, it automatically adds this the number corresponding to that. So to remove that, you put that here. These are all the different escape characters in LaTeX, because as probably using the different modes and stuff like that. Comments use percentage signs, and you'll notice that these are all characters that are reserved, so you have to escape them if you want to use them. And then here's the little bit of some of this interesting stuff. So bold, italics, underline, this is how you do it. Pretty straightforward, intuitive. But the key thing here is that, let's say you want vertical spacing, so we have V space right here. So let's say you want to increase that by, let's go up to 10 points. If we do that, then as you can see, oh, it increased the vertical spacing here. And then horizontal spacing works this way. So if you want to increase that even more, let's say 100 points, as you can see, it moved it more over here. These common thickness of spacing is typically used in equations. So let's say, for example, that what's a common one? Oh, okay, so let's do some like a trigonometric equation. So let's do y equals x sine x. If you do this, well, writing it, wait a minute. Oh, this looks really ugly, right? Because it looks like there's a function called x sine x when you meant to say x times sine of x. So the way you sort of can fix that is if you leave a little spacing, and once you do that, oh, okay, it becomes more clear. You mean x times sine x. You can sort of experiment that. Maybe a thick space is too much. Maybe you want a thin space, maybe a medium space. It's hard to kind of see, but there is a very slight difference in the spaces which can help you with formatting things. But with that, we're going to end on questions right now, if anyone has any, before you guys need to jump to your next class. I have linked a couple different resources in here. I found this pretty decent cheat sheet if you need to look up certain things. And of course, look through all the links left in the slides for the tables, bibliography, and also the, Textify for math. Of course, if you want to learn more specific about LaTeX and Overleaf, you always go to the official Overleaf documentation for LaTeX, which is linked right here. And this is the really fancy part of LaTeX, I like to think. So if you want to create graphs and graphics in LaTeX itself using, because it is a programming language, you could use the TXC package if you want to learn that. I'm not sure if I recommend this for this the scope of GSET because it definitely takes a little bit of time to learn and is definitely tricky. But you could do some very interesting stuff. You actually could write for loops in LaTeX, which is kind of interesting. Yeah, that's, I guess, for another time then. But I guess then we'll go to any questions anyone might have. Oh, the 2-column format. Oh, okay. Lasya answered, yeah.
Yeah.
The template, we'll set that up for you. Anyone else? If anyone wants to see any particular examples, we could try to attempt them right here before we all go.
Yeah, I just want to say that like Google is probably going to be your best friend. Like this is only like a subset of stuff. You're probably going to run into like problems with, actually you will run into problems with formatting. Just don't be afraid to like search it up, and maybe we could help as well with that. So yeah.
All right, but yeah, if no one has any questions, I'm gonna, stop the recording now. Thank you everyone for coming.